Okay, real quick, what's one of the places where limits don't exist? Somebody? Let me ask. Yes, ma'am. Breaking the function. Okay. So piecewise function kind of thing. What's another one? Yes, sir. Vertical asymptotes. You got it. And then the last weird one. Oscillating behavior. Sure. Okay, good. Now, what about this is one where you might have kind of thought, what's he talking about a little bit? This is where we just introduced this yesterday. We'll talk more about this today. What are the three possible results that we can get when we try to directly evaluate a limit? And what's that mean, directly evaluate a limit? Yeah, plug in the numbers and see what we get. What's probably the most common and best result? I would say best, but the easiest. Say it again. Yeah, we get a real number. We get some real number and we're done. That's the answer. Now, can you tell me what that corresponds to in terms of our ant picture? What's that mean if we directly evaluate a limit and we get a numerical answer? Yes, say it again. Good. Okay, so he actually would step where he thinks he's stepping. And so the easiest way to answer where does the ant think he's stepping is to just find out where he would step, right? And that's what we found. So does that make sense? Okay, so that's we might call it a type 1. That's the default. I mean, we get an actual answer. Now the two others that are a little weirder. What's another possibility? Okay, yes, ma'am? No limit. And what's that look like? What would tell us? What kind of answer would we get that would tell us it's no limit? 0 on the bottom, number on the top. Okay, so we get a real number divided by 0. That means no limit. Can you tell me what that looks like in terms of a graph? What are we running into there? Oh, vertical asymptote. Yeah, and that's generally true. That's always true. If we're graphing something and we get the result, a number over 0, that means vertical asymptote. You can associate those two things. Later on in the class, we get to a point, it'll be around, Christmas break-ish, something like that, where we start to use all the calculus that by then we would have learned to do what's called curve sketching. We'll take a function and we'll do the calculus and we'll look at some non-calculus stuff too, like for example this kind of stuff, some limit stuff, because this really is still kind of pre-calculus. And we'll be able to very accurately sketch the behavior of a function by constraining it with vertical asymptotes and horizontal asymptotes and even some slant asymptotes. And then we'll have some other calculus stuff that'll tell us funky things about the function that'll give us a real good solid idea of what it looks like, at least what it looks like at the interesting places. So this is something we'll come back to again and again, this vertical asymptote part. Now what about the third part? This was maybe the one that you might have sounded a little unfortunate to you at first, but it provides us with all the fun we're going to have today, so I guess it's okay. What's the third possibility? Do more work. Do more work. And what's that look like? Okay, 0 over 0. And what it ends up looking like is a hole in the function, exactly. It corresponds to a hole in the function. We get the form 0 over 0, and what that really means, I'm going to make a note of this after I unfreeze the board. We'll come back to this later on in the year also, towards the end, in a little more detail. And when we get a limit that looks like what we talked about yesterday, this third example, the limit of a function equals 0 over 0, this is what we call an indeterminate form, which really makes sense if you think about it, because we don't really know what the answer is yet. We've got to do more work. It was yet to be determined. And so that's an indeterminate form. There are some other indeterminate forms that we'll look at later. For example, infinity over infinity is an indeterminate form. 0 times infinity is an indeterminate form. And there are some others too, but the one that we're mostly concerned with is this guy. And for now, that's the only one we're worried about. Okay, so let's take a look at these limits one at a time here and see what we get. What if I take, okay, so what if I take this guy and put him on a new page, how about? Talk to me about that one. What do we do?
Plug in -2.
Okay, plug in -2. We'll try to evaluate it directly, and we'll just see what happens. If I plug in -2, I get the answer on the top. Let's see, 4 minus 6 minus 10. So what is that?
-12.
On the bottom? 0. Okay, so what's that telling us? No limit. Yeah, done. That's kind of nice. And graphically, what's going on? Vertical asymptote. Yep, good. Good. Okay, let's try another one. Let's try this guy. How about that one? Oh, yeah. Yeah, you should get one of these. These are kind of fun. Yes. Okay, what about this guy? Plug it in. If I plug it in, what do I get? What's the top work have to be? -12 over, which is done. That's our answer, right? No problem. Okay. And last but not least, maybe we'll just do this one right here. What's this one give us?
0.
As you might expect, the third possibility. This is going to give us 0 over 0. More work. Okay, so what's our strategy? Do you remember? Okay, factor it. Good. Our goal here is we want to try to factor the top and the bottom. And if we're able to do that, and by the way, this will always work. We can. Yep. Uh-oh. Did I mess it up? Oh, okay. Whoops. Thank you. I just seen if you're paying attention. Glad you caught that. That would have not worked well for us if we'd done the whole problem that way. So, yeah, the goal here is to factor the top and the bottom, and then we're going to cancel the offending factors, cancel the factors that are causing the zeroness on the top and the bottom. So if we factor the top, what do we get? X minus 5, x plus 2. On the bottom, we get x plus 2. And that is great because algebraically, those factors cancel, right? Now, remember that if I actually do cancel those factors, I am changing the function though, right? It's no longer the same function, but we're trading our original function for a new one. How does it look compared to the original one? It looks the same, except what's the one difference? It fills in the hole, right? Okay, it conveniently fills in the hole, so we're able to turn it into one of those type 1 limits where we can evaluate it directly. And what's our answer then? -7, sure. So that's the y value that the ant anticipates stepping on with the original function. Okay, make sense? Okay, so let's look at another type of these. This is, I don't know what the technical name is for that problem we just did. I guess you'd probably call it a rational function type limit. But let's look at some other limits that also exhibit this indeterminate behavior and talk about how we can deal with them. How about something like this? Okay, so what happens there? I mean, what do I always try to do first? Directly evaluate. But what's going to happen here? 0 over 0, so indeterminate, more work. Now, suggestions. Clearly, that's not something that's going to factor easily, is it? Yeah. I mean, you could probably make that work, but it would be a real exercise. It wouldn't be something that wouldn't be easy. Now, here's kind of the key, though. What's the part? Let's sort of dissect this analytically here. What's the part of that function that's the most problematic for us?
Square root.
That's square root, isn't it? Because the square root doesn't work well with the non-square root terms. They don't play well together, right? What we'd really like to do is we'd like to change this function so that the part that's causing it to be 0 doesn't involve a square root. Okay, the problem is if I plug in 3, the top of the function is 0, and that's unfortunately got a square root added with a non-square root term. So we want to tweak this thing around a little bit. We're probably going to get stuck with square roots in this someplace, but we'd rather that the square roots showed up in a more convenient way. And that probably doesn't make total sense, but we'll come back at the end and revisit that statement and see if it does make more sense then. Any suggestions? Okay, we could try squaring the whole thing. Let's see what happens. But hold it now, if I square the whole thing, okay, if I square the whole thing, aren't I changing the function in a way that's pretty dramatic? Right? I mean, in the last case, the only way we changed the function was by just canceling out common factors, right? Now, we can tweak algebraically, we can tweak stuff, that's fine, in ways other than factoring, which clearly we're going to have to do. But we don't want to fundamentally change the whole function, do we? We're going to end up maybe filling in a hole, but that's a pretty minor change. If I square this thing, I mean, think with that normally, if you think about a normal function, like if I took something like, y equals x squared plus 1, and I square that, that's dramatically different. The graphs look really a lot different, right? So squaring it, I can see the suggestion where it comes from, because we got that darn square root there, right? But we got to limit ourselves a little bit. Now let's talk about what are some safe options for us in terms of how we can manipulate a function algebraically. What are the things I can do, sort of generally speaking, qualitatively, that won't change the function? Yes?
Multiply the top and bottom by the square root.
Okay, okay. Now what you're getting at there is one thing we can do is we can multiply a function by 1, and 1 is what we call the multiplicative identity. Right? It's the identity number for multiplication. It doesn't change anything. Any number times 1 is itself. So why would we multiply by 1? Well, we don't multiply by 1 just written as a 1. We multiply 1 in a convenient form, maybe as something divided by itself. Okay? The other thing we can do, does anybody know what that is? What's the number we could add to something and not change it? 0. Now that's a weird one. That's you don't see that as often in algebra. We'll look at a couple proofs this year where we very sneakily add 0 to make things work the way we want them to, but that's more rare. Typically we multiply by 1 though, and that's a great suggestion. What's your motivation for that? That's a great idea.
I just thought I'd throw that out there.
Okay, your intuition was good. Multiplying, now let me repeat what was said there. And that's 1, right? Yeah. 1 had a great idea here. If we multiply by the conjugate of the top, and both the top and the bottom of the fraction, that's a great idea. Think what multiplying by a conjugate does. So we got the square root of x plus 1 plus 2 divided by itself. Now if we go back to like Algebra 2 days and we talk about multiplying by conjugates, if I have a plus b times its conjugate a minus b, and you know what I mean when I say conjugate, right? We've got two terms that are being combined by addition in one factor and subtraction in the other. We'll multiply those together. What's that result? That's good. That's a perfect, well, it's a difference of squares, isn't it, right? A squared minus b squared. Now what's convenient there is the squares. Look at that, right? That's going to work great for us because instead of an a, we've got a square root of x plus 1, and instead of a b, in lieu of a b, we've got a 2. Right? And so when we end up squaring those two terms, that's going to help us out immensely. Okay, so let's watch this in action. Now notice that I'm dragging that limit notation with me each step of the way. There's a real tendency in math, especially with intensely smart people like you guys, to want to get to the answer right away and to take some little shortcuts like not writing that limit notation. That's not correct though. We haven't evaluated the limit yet, or in math speak, we haven't taken the limit yet. So we have to keep that limit notation out front. Okay? That has to be there. And, well, enough said for now. So if I do multiply these conjugates out, what am I going to get on the top? X plus 1 minus, so first term squared minus second term squared, okay? Now the bottom looks pretty ugly, but that's a good trade, and we'll talk about why here in a second. On the bottom I've just got x minus 3 times that factor, square root of x plus 1 plus 2. And at first blush you might say, well, what good did that do? We still got some ugly on the bottom. Okay, but watch what happens when we evaluate this thing, or when we simplify it. On the top, what is x plus 1 minus 4?
Minus 3.
X minus 3. Aha.
You get those wrong.
Oh my.
Look what happens. What's my next obvious step there? Cancel the common factors, right? So I can cancel those two guys, leaving me with a 1 on top, right? And those are the factors that was causing this indeterminacy, right? That's what was giving me the 0 over 0, okay? So then what I'm left with is a new function. 1 over the square root of x plus 1 plus 2. It still looks pretty ugly, but now what happens when I take that limit or evaluate the limit? Yeah, I get a number, right? I get 1 over, so 1/4. Okay? Now, for the first time, I don't have to write that limit notation anymore in front because I actually evaluated the limit, and that's my answer. Okay, make sense? So as a general rule then, how could we distill this down to a kind of a technique or a rule for us? Well, when we see something that looks like that, where I've got a square root involved in a sum or difference that's going to 0 in my limit, and I've got a 0 over 0 type limit to start with, I always multiply top and bottom by the conjugate of that factor, right? Okay. So we get a chance to practice those. All right. Let's try another one. Okay, what about something like, how about this? Okay, what do you suppose is going to happen if we try to evaluate directly? 0 over 0, sure. Okay, now to me this one's pretty straightforward. I think of all the ones we do, in a way, the strategy is the most obvious here. What do you think you do? Maybe. Maybe. Okay. What's?
I want to get rid of the x.
Right. We're going to want to get rid of the x on the bottom. Now, in the prior problems that we looked at, let's just quickly review. That first one, you know, we factored. Where was that first one? Oh, back here. That first one we factored the top and the bottom to get those factors to cancel, right? Second one, we had to multiply top and bottom by a conjugate to get the thing to be rewritten, for us to algebraically manipulate it so that those factors could cancel.
Can you multiply by inverse, because this is technically 1 over x, wouldn't you do x over 1?
Sure, yeah, we can. In fact, that's one thing we may end up doing at some point. We may end up multiplying by the reciprocal of the bottom to make it a product instead of a quotient. But when I've got a problem like this, where I've just got a mess of a bunch of fractions in the numerator and fractions in the denominator, I'll take you back to the days of Algebra 2 for a second. We want to simplify this thing so we've got one big fraction on the top and one big fraction on the bottom, right? So this one actually just works out to be a bunch of simplifying, and then as a process of simplifying it, the factors will pop out, right? So most of the work is going to clearly be in the top. If we want to turn this whole numerator into one big fraction, what do? Got to get a common denominator. I've got to combine those two fractions, right? So what am I going to multiply the first fraction by? By 1. In what form? What over what? 4 over 4, sure. Okay, so. And then the second one. Good. Okay, very good. So, so then in the top, that's going to give us our common denominator of 4 times x plus 4. So we're just working in the numerator for now. What's going to be in the numerator of the fraction in the numerator? I've got
4.
Good. I've got 4 minus x plus 4, right? Make sense? Then on the bottom, I've still got my x. So we could simplify this. So what is 4 minus the quantity x minus 4? If I distribute the negative sign and combine like terms, we'll just do that in our head. What do we end up with up here? Negative x, okay. So I've got negative x over 4 times x plus 4 all over x over 1. There comes our x over 1. And now what? How about flip and multiply? Good. Okay, so we get, I've got this guy times the reciprocal of this guy times the reciprocal of that guy, right? So negative x over 4 times the quantity x plus 4 times 1 over x. Well, what's happening there? Yeah. It happened again, right? The offending factors, as x approaches 0, these are the two factors that are going to 0, right? Those are the ones we need to cancel, and they do cancel. And so we end up with the limit of, on the top, we've just got a negative 1 over 4 times x plus 4 as x approaches 0. So now I can take my limit, evaluate directly, and what do I get? Yeah, negative 1 over 4 times 0 plus 4 is just 4 times 4. Negative 1/16. How about that? Okay. Make sense? Okay. What time is it? 12 o'clock, yeah. Oh, is there a clock down? Oh, right there. There we go. Duh. I didn't think about that. Okay, so it's probably not worth going down. Well, let's try another one. I'll give you a little time to work on this tomorrow. And I got thinking, how about on the review assignment, that second one? It sounds like that one's, how many people are, anybody done with the second one? Second review? A couple people, but. Okay, so messed up meaning it's hard messed up or it's not working messed up?
It's hard.
Hard. Okay, I'm gonna do this. Those review assignments really are not meant to, I think I was a little ambitious with those dates because I didn't have the calculus assignments up yet, but those are really just for you guys to kind of mess around with on the side between calculus assignments. So I'm going to push that one out like a ways. And I'll just kind of add those. As long as we get all the review done in the first month and a half, I'm totally fine with that. Those are just sort of there for, make you think a little bit, kind of inspire you to think about some of the topics that we'll eventually be talking about. Get a little bit, but they're not that big a deal. How about if we push that out till, like, I don't know, next week, midweek next week or something. I'll change that date.
Did you
So-
put up another assignment last night?
Say that again.
Did you put up another assignment last night?
Should have. Well, let's look and see. There should be one more up there. Oh, I want to show you. I know what else I need to show you. Something else. Let me show you two things here. Okay. I want to show you where the lecture videos are. So if you log into Moodle, and I'm going to log in as a student here, so you can. I'll see what you see. Yeah, you guys won't see that. That's okay. There's what you see. There's what you see right now in calculus. I've got some Khan Academy stuff up there, which is, it's not bad. It's probably second priority, but it's there. But if you go to the lecture videos, I'll just have them indexed by chapter. So if you go to chapter 1, it'll just pull up a little page, and then there are in order by date. There are the lectures. And what happens if you pull these up? And this is embarrassing for me. I hate to hear myself talk, but I'll do it anyway. It'll just go to a YouTube video, and I don't know why these aren't showing up in HD, but oh well. And of course, you have the ability down here to kind of, just go to the part. If you had one little question on something you didn't get, you can kind of use these little snapshots to scan through it and just find the part that didn't make sense. Or if you're gone on an athletic trip, you could even do this on your phone on the bus. So I'll try to get them up there pronto. So they're by today at lunch, I'll try to put up today's video. So yeah, that's where those are. Let's take a look at the other site and make sure the dates are good. Okay. What do we got for dates here? So we got pre-calculus review number 2 I need to change. So how about, let's say, would October 3rd be reasonable? That'd be a Wednesday, is that okay? Like a week from tomorrow? Okay, and the other assignment. Okay, so the next one, how about if we do that like next Wednesday too? This first. October.
Yeah, you're in 2011.
Oh, yeah, I am.
It's not good.
Yeah.
It was due last.
Yeah. So all I have to do is travel back. I gotta be a looper. I gotta travel back in time and turn that in. Yeah. All right.
So, Troy, what's the last part of number 6 on finding the limit graphically and numerically?
What? Say it again.
On the finding limits graphically and numerically, you know number 6 on the very last part?
Pull it up. Yeah. Okay. All right. We got a question. Got a question. Let's take a look at this here. Oh, yeah. Was that the one where they're asking for domains and ranges?
Yeah.
Okay, yeah, let's look at that. That's a good one. Yeah.
I got the domain and the range.
Okay. All right. Yeah. This one. We want to look at this one. Oh, I can't make those bigger. Huh. Can't make this very big. Sorry. All right. So what do we do with this? Let's talk about this guy. Oops. Hang on here. All right, so they want us to find a graph of the function, then answer these questions. What are domain and range? At what points does it exist? And we'll talk about that. First of all, I mean, what is that? Piecewise function. We're all familiar with that and know how to deal with that. Okay, let's review. If I've got something like this, man, this thing's not working very well. Technical issues. Okay, so what this is really saying then is we've got this function that is defined as having three distinct behaviors, right? It's got three different patterns that it follows based on where you are in the domain, right? So when x is greater than or equal to 0 and less than 5, this is the behavior that the function follows, right? When x is greater than or equal to 5 and less than 10, y equals 5. And when x equals 10, at that one value of x, we define the y value as 10, right? Okay, so if I were to graph this thing then, oh, that's why. There you go. Excellent. That's it. There we go. Okay, so the fun is on fire today, man. All right, so if I graph this thing in between 0 and 5, I've got the square root of 25 minus x squared, which is just going to look like this. Okay, and how did I get that? Let's just kind of do a little pre-calc talk here for a second. How did I get that so fast? It looked impressive, but it's not that big a deal. How would I manipulate that function in a way to kind of get an idea what it is? Okay, it's, yeah, okay, well, but it's a square root one. What if I squared both sides here? What if I squared both sides of this function? I'm going to get y squared equals 25 minus x squared, right? Isn't that the same thing if I add x squared to this side as that? What is that? What is that if I graph that non-function, right? It's just a relation. It's certainly going to violate the vertical line test, but what is that if I... Circle centered on the origin with radius 5. Yeah, so that's really, that's all I'm drawing is just the top part of a circle. So it wasn't that tricky after all, was it? No. Okay, so that's, if we go to this behavior then, now I got to be careful with this. Oh, I'll be careful with it tomorrow. Get out of here.